Okay, so hello and assalamu alaikum to you all. My name is Mohammad Sheikh Lias Ram School and Academy in Basman. So today we're going to talk with Maya on the topic air. So hello Maya, how are you?
Hi, welcome back. I'm doing well. Thanks for asking. Assalamu alaikum to you too. Sounds good that you're back with the Academy in Boston. I hope things are going well there. I'm ready when you are to dive into whatever topic you've chosen. What are we going to explore today?
Today we're going to talk about air. So my first question with you is, what is the air? Please explain that in detail.
Okay, so you want me to explain AKIT in detail for at least a minute? Well, the letter A present is quite fundamental, actually. It's the first letter of the English alphabet, of course, and comes from the Phoenician letter aleph, which originally meant oxus. That's pretty ancient history. But what makes A special isn't just its origins, it's its versatility. In terms of pronunciation, it's a vowel sound made when your mouth is relatively open, depending on the word. You have the short A sound like inapple, and the long A sound like inape. It's incredibly common. It appears in tons of English words, probably one of the most frequent letters you encounter. But here's where it gets a bit more interesting.
No, no,
A
no.
stub isn't.
No, Maya.
Sorry.
We are going to talk on the topic air, not the letter A. We are going to talk about air, AIR.
My apologies. Okay, so we're talking about AI, artificial intelligence. Artificial
No,
intelligence at its
no, Maya, we are not talking about artificial intelligence. We are talking about air, like wind, not the wind, like
ah,
air. Air,
my
which is.
apologies for the
Yes, yes, continue.
ah, air. I get it now. So air is essentially the mixture of gases that surrounds the earth and makes life possible. It's primarily nitrogen and around 78% and oxygen about 21%. The remaining 1% is made up of argon, carbon dioxide, and other trace gases. Air isn't just one thing, though, it has layers. The troposphere, where most weather happens, is the lowest layer. Then you have the stratosphere, where planes fly, the mesosphere, thermosphere, and exosphere. Air pressure also plays a huge role. That's the weight of all that air pressing down on us. And it changes with altitude. Without air, we couldn't breathe. And frankly, most life wouldn't exist. Plants use carbon dioxide from air to make food through photosynthesis. Air is essential for combustion. Think of fire. It's involved in all sorts of natural processes like weather patterns, wind currents, and keeping our planet habitable.
Okay, Maya, so our next question is, can we see air?
Yes, I'm listening for your next question.
I will repeat the question. So my question is, can we see the air?
That's a good question. We can't directly see air most of the time, that's right. Air itself is mostly colorless and odorless, that's why it's invisible. But we can see the effects of air when it moves as wind, causing trees and leaves to rustle. We can see fog or mist, which is essentially water droplets suspended in air. You can also see air movement through things like smoke rising from a fire or steam coming off a hot cup of tea. Those particles show us the invisible air currents. Another way to see air is through ripples on water. The wind pushes against the water surface, making waves. Even when air warms up, it rises, creating thermal columns, like the shimmering heat you see above asphalt on a hot day. That's air changing temperature and becoming visible through distortion. So while air itself is invisible, we experience its presence and can sometimes see its effects.
Okay, Maya. So my next question is, can we feel air when the wind blow?
Yes, absolutely, we can feel air when the wind blows. In fact, feeling the wind is one of the primary ways we experience air directly. Wind is literally just moving air, and when it blows across your skin, it causes a physical sensation. That feeling can range from a gentle breeze to a strong gust that pushes against you. It's because air molecules are physically colliding with the nerve endings in your skin that trigger that sensation. Different air temperatures also impact how the wind feels. A cold wind feels harsher than a warm one because it rapidly draws heat away from your skin. And the speed of the wind also changes how you feel it. Lighter breezes can be refreshing, while stronger winds can feel disruptive or even dangerous. Air pressure and humidity also affect perception. High pressure systems tend to feel still and settled, while low pressure systems often bring windier conditions. So, yeah, feeling the wind isn't just detecting something, it's actually sensing the physical impact of those moving air particles around you.
Okay, Maya, so my next question is which gas in the air help us breathe?
I think I missed what you said. Could you repeat that? You
Okay.
said with gas.
No, I
Sure,
was,
what's
I was asking you that which gas in the air help us breathe?
oxygen. Oxygen is the gas in the air that helps us breathe. Our bodies need oxygen to function. Basically, every cell in our body uses oxygen to create energy from the food we eat. When we inhale, our lungs extract oxygen from the air and transfer it into our bloodstream. That oxygen then gets carried to all the tissues and organs so they can do their jobs. Without oxygen, our cells can't produce enough energy to keep us alive. It's a continuous process. We're constantly taking in oxygen and releasing carbon dioxide, which is essentially a byproduct of that energy production. So, oxygen in air is absolutely vital. That's why we focus on breathing clean air with a high oxygen content. What keeps us going? I think you're asking if plants need air. Is that right? Yes, absolutely. Plants need air, though they use it in a different way than we do. Plants actually need carbon dioxide, which is a gas in the air, about 0.04% of the air we breathe out. During photosynthesis, plants take in carbon dioxide and water and use sunlight to convert them into sugar for energy and release oxygen as a byproduct, which is what we then breathe in. So while we need oxygen, plants need carbon dioxide, and the two processes actually complement each other. Plants also absorb some oxygen for respiration, similar to how humans do, but their primary need is for carbon dioxide. Essentially, plants are taking the waste product of our respiration, which is carbon dioxide, and turning it into the oxygen that we need to survive. So it's a cycle. Yes, I'm. Yes, animals definitely need air, just like humans do. Most animals get oxygen from the air through their lungs, taking it in when they breathe. The oxygen goes into their bloodstream and is carried to all their cells to provide energy. Of course, animals also release carbon dioxide as they breathe out. It's the same process as with humans. There's a range of adaptations. Fish extract oxygen dissolved in water through their gills. Insects have tiny holes called spiracles that allow them to take in air directly. And amphibians, like frogs, can absorb oxygen through their skin. But all animals, whether they live on land or in water, need oxygen to survive. Without air to breathe, most animals couldn't get the energy they need to function and would quickly suffocate. That's a really good question. Yes, air absolutely takes up space. Even though we can't see it, it has volume, just like liquids or solids do. You can demonstrate this with a simple experiment, like filling up a balloon with air. The balloon expands because you're adding air inside that's taking up the room within it. Another example is pumping air into a tire. The tire expands because the air takes up space. Air is made of gas molecules moving around, and those molecules occupy a specific volume. In terms of taking it to space, that's a bit different. Space is mostly a vacuum, meaning there's very little air or matter. While there are trace amounts of gases in space, they're incredibly spread out, not compressed like air here on Earth. When astronauts go to space, they have to carry their own supply of air to stay alive because the space environment doesn't have enough air to breathe, and the very low density of air there can't sustain life the way air on Earth can.
Okay, Maya, so my next question is, does air have weight?
Yes, air does have weight, though it's not something we typically notice in everyday life. It's because air is made of gases like nitrogen and oxygen, and all matter has mass. Mass is what gives something weight. The air around us has weight, and the force of gravity pulls it downward. That's what creates air pressure. We can't feel it because the weight is distributed over such a large area. But we can't actually measure this. If you were to trap some air in a closed container and weigh it, you'd find that the container weighs more with air inside than without. This principle is even used in airships and hot air balloons. Warmer air is less dense and therefore lighter than cooler air, allowing those balloons to lift up. Air has weight, just like anything else with mass.
Okay, Maya, so my next question is air everywhere around us?
Yes, there's air everywhere around us. So air surrounds the earth completely. From the very highest mountains to the deepest oceans, you find air or gases acting similarly. Obviously, underwater, there's water, but even that has air mixed in. Even inside buildings, air is all around us and constantly flowing around and through spaces. While there's less air the higher you go up, like on mountaintops, it's still present. And even in what seems like empty spaces, like between you and the wall right now, there's air filling the gaps. So it's difficult to escape air completely. Air really is universal in our Earth's ecosystem. It's everywhere from outer space to underwater and fills every little spot around us.
Okay, Maya, so my next question is, what do we call moving air? Like you explained it in detail.
You mean moving air? Well,
Yeah.
we call moving air wind. Wind is essentially what we call air in motion, a result of differences in air pressure. Air always flows from areas of high pressure to areas of low pressure, and that movement creates wind. There are different types of winds. You have gentle breezes, steady winds, strong gales, or even destructive hurricanes or tornadoes. Winds are categorized based on their speed and direction. On a smaller scale, things like the wind on your face during a bike ride or the breeze rustling leaves, it's all just moving air. But bigger patterns form large scale weather systems with prevailing winds that can travel thousands of miles, things like the trade winds, the jet stream. So essentially, when air moves, we call that wind, whether it's a light breeze or a powerful storm system.
Okay, Maya, so my next question is, can
I'm listening. What's your next question?
okay, so can air fill a balloon?
Can you fill a balloon with what? With air? Yes, absolutely. That's one of the classic ways to demonstrate that air takes up space, like we just discussed. You blow air into the balloon and it expands. That's because air is made of gas molecules, and when they enter the balloon, they fill it up and press against the rubber. The tighter the balloon gets filled, the more that air is pressing on inside. And eventually, if you keep blowing, the balloon will pop from the pressure. It's a simple way to show that air has volume and weight, something that's invisible, but you can physically demonstrate it right there in front of you by blowing up your own balloon.
Okay, Maya, so my next question is, can air fill a like tire?
Yes, you can definitely fill a tire with air. It works the same way as filling a balloon, but tires are made to hold more pressure and air. You use a pump, whether manual or powered, to push air into the tire. The air pressure inside a tire is important for how well the tire works and how safe your vehicle is. That air compresses, gets packed together inside the tire, providing support and maintaining the tire shape so that the vehicle drives smoothly. So, like the balloon, filling a tire also demonstrates how air can fill space and exerts pressure when it does. The air in your tires is just another way that shows air has volume and force.
Okay, Maya. So my next question is air important for fire to burn?
Yes, air is absolutely essential for fire to burn. Fire actually needs three things to exist: heat, fuel, and oxygen. Oxygen, which makes up about 21% of air, is what combines chemically with the fuel. That combination process called combustion, it creates heat and light, which is what we know as fire. If you cut off the supply of air to a fire, it with a blanket or dousing it with water, which creates steam to displace the oxygen, the fire goes out because it can't get the oxygen it needs to keep burning. The air's oxygen is the spark. That's why you can't have fire in space where there is no air. Basically, without the oxygen that's in air, fire simply cannot exist because combustion needs oxygen molecules to react.
Okay, Maya. So my next question is, can we live without air?
No, we cannot live without air. Human beings need air, specifically the oxygen in air, to survive. Our bodies require oxygen for a process called cellular respiration, which is how we turn food into energy. We use oxygen in every breath we take, and without it, our cells can't function. If we stop breathing, we lose oxygen from our bodies, and without it, organs start to shut down very rapidly. No oxygen for even a few minutes can cause serious brain damage or death. So the answer is absolutely no. Human beings would not survive without air. That's why being able to breathe clean and sufficient air is necessary, and why we can not breathe in locations where air isn't present.
Okay, Maya. So my next question is air a mixture of gas?
Yes, air is absolutely a mixture of gases. It's not just one single type of gas, it's actually quite a complex combination. The main ingredients are nitrogen, which makes up about 78% of air, and oxygen, making up around 21%. But there are also smaller amounts of argon, which makes about 0.9%, and then tiny amounts of gases like carbon dioxide, neon, helium, methane, and hydrogen. Trace amounts of other gases are also present. This mixture is fairly consistent around most of Earth, though the exact percentages can change slightly depending on altitude and local conditions. These gases don't chemically combine with each other, they simply coexist together, filling the space and creating what we experience as air. The fact that air is a mixture of these different gases is how we have different qualities in air, like humidity and air pressure.
Okay, Maya. So as you were telling that nitrogen is present more in our gases is nitrogen is more. So please can you explain us what is nitrogen and what is the use of nitrogen in like Earth? What the nitrogen help us?
Absolutely. Okay, so nitrogen is a colorless, odorless gas that makes up around 78% of the air we breathe, as we talked about. It's actually incredibly important for our planet in several ways. Even though we can't use nitrogen gas directly, plants actually need it to grow. A process called nitrogen fixation converts nitrogen gas into forms plants can use, like ammonia, through bacteria in the soil. Plants use that nitrogen to create proteins and DNA, the building blocks of life. Without nitrogen, plants wouldn't be able to grow, which affects all life on Earth. Nitrogen is used in manufacturing processes as well for fertilizers, which help boost crop growth. It's also in explosives and plastics, too. When we talk about Earth's atmosphere, the nitrogen gas acts a bit like a blanket in the air, moderating temperature, when it helps create balanced and sustainable growth patterns.
Okay, Maya. So my next question is, do birds need air to fly?
I think your question is, do birds need air to fly? And the answer is absolutely yes. Birds need air to fly. Birds need air in a couple of crucial ways for flight. First, like all living things, they need oxygen from the air to provide the energy for their flight muscles. Secondly, the air itself is what allows birds to stay afloat. Their wings are specifically designed to interact with air molecules. As they move the air over and under their wings, it creates lift. And air resistance is important too. Controlling the airflow allows birds to steer. Finally, birds rely on air currents and wind patterns to help propel them forward or even gain altitude without using all their energy. The shape and design of birds' wings are meant to use air to fly.
Okay, Maya. So my next question is, do fish use oxygen for like from water? The fishes take the oxygen from the water or not? They come up and take the oxygen. Explain it in detail, please.
That's a really insightful question. Fish don't actually breathe oxygen directly from the water the way we breathe air. Instead, they extract dissolved oxygen that's mixed into the water. Water has oxygen molecules scattered throughout. Fish have organs called gills that are designed to take that oxygen out of the water. Think of it like your lungs pulling oxygen from the air, but water molecules and oxygen go through fish gills. So when fish open their mouth or move water over their gills, these organs filter out oxygen that's already dissolved in the water. Some fish occasionally come to the surface to gulp air because the water might not contain enough oxygen or they need extra in certain scenarios. But generally, fish take their oxygen from the water, but they need oxygen in water to breathe and survive.
Okay, so thank you, Maya, for giving us your precious time and talking for us on the topic here. So we meet in another session, like a session with Maya on different topic. So bye bye, Maya.
You're so welcome. I really enjoyed talking about air with you today. It's such a fundamental part of everything. I look forward to chatting with you again in our next session on whatever topic you choose. Take care.
Bye bye.
Bye.